Question 1 is all about forces on a slope. The first thing they asked us to do is draw and name the forces that are acting on the block. Clearly, the block has got weight, which will act vertically downwards. In addition, because it's touching a surface, the normal reaction force acts perpendicular to that surface. And we've got friction, which opposes motion, so that will act up parallel to the slope. Part B then asks us to calculate the acceleration of the block down the plane. Let's identify from the question what we have been given. So it says the angle of the incline of the plane is 50 degrees. The block takes 1.8 seconds, so we have got t. And it says that it's to travel 4 meters, so we've also got s. The block starts at rest, so we also know that u is equal to 0. It's asking us to find a, so we need to find an equation that has t, s, u and a in it. The Suvat equation that works is s equals ut plus a half at squared. What we then need to do is rearrange it, because we're being asked to find a. We know that u is equal to 0, so that one we can cancel out, which means that a is equal to 2s over t squared. If we plug in the numbers then, 2s is 2 times by the 4 meters, and we're dividing that by t squared, which is 1.8 seconds squared. When you plug all of that into your calculator, you should come out with an answer of 2.47 meters per second squared, don't forget, because it's acceleration. The second part of B is asking us to find the component of the weight down the plane in terms of m. So if we go back to the diagram, it's now asking us to resolve this force here into its separate into its separate parallel and perpendicular components. So it's asking us for the component of this which is down the plane, so that is this one. We know that this angle here is also equal to theta, which is 50 degrees. Okay, this sine here is opposite to that angle, so therefore it's w sine theta. I'll just go back down to the bottom. W we know can be rewritten as mg, so that's mg sine theta. G sine theta we can put into our calculator because we know that's equal to, or theta is equal to 50 degrees. G is equal to 9.81, and that should come out that the component of the weight down the slope is equal to 7.51 m in terms of the mass. Part C is asking us to calculate the frictional force in terms of mu k and m. Hopefully you remember, or you can find in the formula booklet, that F is equal to mu k n, where n is the normal reaction force. If you go back to the diagram on the previous page, you can see that n is the force in the opposite direction is the component of the weight which is going into the slope or perpendicular to the slope, which is equal to mg cos theta, which in this case is 50 degrees. If we plug that into our initial expression for frictional force, that gives us that F is equal to mu k mg cos 50 The g cos 50 we can plug into our calculator to get an expression just in terms of mu k and m, and that comes out as 6.31 m mu k. The final part of question 1 asks us to calculate the value of mu k. In B part 2 we worked out the component of the weight which was acting down the slope, and we've just worked out the frictional force which is acting up the slope. Those two forces are acting in opposite directions but have caused an overall acceleration. So we know that the F net, the net force acting down the slope, is equal to the original component of the weight, which was mg sine theta, that's the component of the weight acting down the slope, minus this frictional force which is acting up the slope, which is 6.31 m mu k. If we then replace this expression with the one that we calculated in B part 2, we can see that the net resultant force, or the net or resultant force, is equal to 7.51 m, that's our expression from B part 2, minus 6.31 m mu k, sorry about my handwriting, and that overall is equal to the resultant force. We calculated earlier on the acceleration down the slope, so all of this net force is equal to ma. We can see here that there's an m in each of these three expressions, so we can cancel those out, and we're left with 7.51 minus 6.31 mu k is equal to a, which from our earlier question, B part 1, is 2.47. If we rearrange this and solve for mu k, you should get the fact that mu k is equal to 0.80.